In the next couple of lessons, we're going to work with some laws to help us solve triangles. So just like in the real world, we have laws such as the speed limit on Highway 16, which is 55, that many of you, I'm sure, disregard. In mathematics, we have the law of sines and law of cosines, which is going to help us solve any triangle. In the past, we've mainly worked with solving right triangles using SOHCAHTOA. Now we can solve using the law of sines and law of cosines any triangle, which allows us to work with more application problems. Solving triangles simply means that we're finding all three lengths and all three angles for that given triangle. In the past, we used SOHCAHTOA to solve for right triangles. Now we're going to be able to solve for any triangle using the law of sines and the law of cosines, which we'll talk about in the next lesson. So what the law of sines says is, in any triangle with angles A, B, and C, and opposite sides A, B, and C respectively, the following equation is going to be true. The sine of angle A over side length A will be equal to the sine of angle B over side length B, which will also be equal to the sine of angle C over side length C. So we're going to focus just on two of these parts and fill in three of the pieces of information that we have so that we can solve for the one unknown value. Example 1, we want to solve triangle ABC. So we know that the measure of angle A is 36 degrees, the measure of angle C is 48 degrees, and side length A is 8 units long. So if we're going to solve this, we need to find the missing angle, angle B, and side lengths B and C. The first thing we should do, and probably the easiest thing, is to find the missing angle, because if we have two of the angles, all we have to do is take 180 minus 36 minus 48, which leaves us with the measure of angle B being equal to 96 degrees. So next we have to find side length B and side length C. It doesn't matter which one we solve for first, we can go for side length B. Now we're going to have to use the law of sines. So since we know the value of angle A and side length A, we want to use that ratio. So we're going to set up the sine of 36 degrees, which is angle A, over 8. Set that equal to the sine of 96 degrees, because that's what we found for the measure of angle B, over side length B. We could also use the reciprocal identity from solving proportions in geometry to make this easier to solve. So we would get 8 over the sine of 36 degrees equal to B over the sine of 96 degrees. This would be easier to work with because the value we're looking for is in the numerator of the fraction. Now to get B isolated by itself, we would multiply both sides by the sine of 96 degrees. So now we get B equal to 8 times the sine of 96 degrees divided by the sine of 36 degrees, which, if you plug it to your calculator and make sure you're in degree mode, is approximately 13.54. Now we're going to use a similar process to find the length of side length C. So we could set up C divided by the sine of 48 degrees, set that equal to 8 over the sine of 36 degrees. Then if we solve for C, we have to multiply both sides by the sine of 48 degrees. So we get C equals 8 times the sine of 48 degrees divided by the sine of 36 degrees, which is approximately 10.11 units long. So now we have the missing angle and the two missing side lengths. One thing we can do now that we have all the information is to check and see if our results are reasonable. Because we know if we have a triangle, the smallest angle is going to be opposite the shortest side, and the largest angle is going to be opposite the longest side. So if we're looking at our side lengths, our original side length was 8. Now we know that C is 10.11 and B is 13.54. So 13.54 is the longest side. So that should be opposite of the largest angle. So here's 13.54, opposite of 96 degrees. So that works. Smallest angle was 36, opposite the shortest side. So that's one quick way you can check to make sure your results are reasonable. Example 2, now we want to solve this triangle. And in this one, we know the measure of angle A is 26.3 degrees. And we know side length B is 6 units long. And side length A is 7 units long. So we need to find the measure of angle B and the measure of angle C. And we also need to find the missing side length C. First thing we can do is use the law of sines to find the measure of angle B. So using the law of sines, we get the sine of B over 6 equal to the sine of 26.3 over 7. Next, we would have to multiply both sides by 6. So we get the sine of B equal to 6 times the sine of 26.3 degrees, all divided by 7. Now, since we're trying to get B isolated by itself, that angle, we need to get rid of this sine function. So we have to take the inverse sine to each side of this equation. So we have to take the inverse sine of the left side of the equation as well as the inverse sine of the right side of that equation. Because if we take the inverse sine on the left side, that's going to get the inverse sine and the sine to cancel out, leaving us just with the measure of angle B. If you use your calculator to type in the inverse sine of 6 times the sine of 26.3 degrees divided by 7, you get B to be approximately 22.3 degrees. So now we know the measure of angle A and the measure of angle B. To find the measure of angle C, we just have to take 180 minus 26.3 minus 22.3. So for the measure of angle C, we get that to be equal to 131.4 degrees. And that would actually be an approximation because we rounded the value for B. Now the only thing we have left to find is side length C, so we can set up the law of sines to find that missing side length. So you can set up C over the sine of 131.4 degrees, set that equal to 7 divided by the sine of 26.3 degrees. Then you isolate to get C by itself, and if you plug that into a calculator, you get C is approximately 11.85 units. Again, you could check to make sure your results are reasonable. Our smallest angle is angle B, so that should be opposite the shortest side, which is 6. The longest side was C, which is 11.85. That should be opposite the largest angle, which it was 131.4. Example 3, we have an application problem. Forest Ranger Muffin is at Ranger Station Man and sights a fire in the direction 32 degrees east of north. Forest Ranger Saka is at Ranger Station Juia, 10 miles due east of Station Man, and sights the same fire on a line 48 degrees west of north. We want to find the distance from each ranger station to the fire. So we can create a triangle to represent the situation. We have Station Man, Station Juia, and the fire. We know the angle between our straight north and the angle it forms east of north to the fire is 32 degrees. Same thing on the other side, except it's 48 degrees, and the distance between the two stations is 10 miles. Using this information, we can find these two angles within the triangle. Because if this is straight north and this is straight east, we know this angle is 90 degrees. So if we take 90 minus 32, that's going to leave us with the inside angle for this triangle, which in this case will be 58 degrees. Using the same idea on the other side, if we would take 90 minus 48, this would become 42 degrees. And now we could find the missing third angle, so 180 minus 58 minus 42 is going to leave us with, that should be an 8, it's going to leave us with 80 degrees. Now we can set up two different equations using the law of sines in order to find these two distances from the stations to the fire. So to find the distance from Station Man to the fire, we could set up Fm over the sine of 42 degrees equal to 10 divided by the sine of 80 degrees, and we get Fm is approximately 6.79 miles. So the distance from Station Man to the fire would be almost 7 miles. Then we could use a similar idea to find the distance from Station Juia to the fire. Fg over the sine of 58 degrees equal to 10 divided by the sine of 80 degrees. Simplifying that, we get Fg is approximately 8.61 miles. So the distance from Station Juia to the fire would be approximately 8.5 miles. In example 4, we're going to show why the side-side angle pattern is not enough to show the size or shape of a triangle. So suppose we have the measure of side length A is 6, side length B is 7, and the measure of angle A is 30 degrees. As you can see down below, there's two different triangles we can create if we have this information that follows the side-side angle pattern. So since there's two different triangles we can create, this shows why we cannot use the side-side angle pattern. Think back to geometry when we were doing congruence theorems for triangles. We had side, angle, side, 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 angle, side, angle. We never went through side, side, angle, and that's because we have this arbitrary situation where there's two different possibilities that could be created.